The O in SOLID stands for Open-Closed Principle, which says that software entities like classes, modules, and functions should be open for extension but closed for modification. Let's see an example of what this is referring to in the editor. For this exercise, I've created two classes, one product and the other order. Product will have three constants which represents different types of the product. Then we have ID of the product, type associated with the given product, name, price, and weight of this product. And then constructor takes these arguments, associates them with the properties. Then what we have is basically a Boolean returning methods indicating whether the type of this product is of a given type. So is gadget, and then we're basically comparing the type ID with the constant type gadget, furniture, and is vehicle. Now order starts with a private items array, which is where all products added to this order are being stored. Then we have this add method, which takes an instance of the product and then quantity of this product. As you can see, I'm using PHP 7 here, indicating what data type I'm going to return, what sort of data is going to be returned when we call this method. And in this specific instance, we are returning itself, basically the order class, because as you can see, return this pseudo variable returns itself. In other words, later on we'll be able to use add method and then chain it with another method of this given object instance. Now from within this add method, we're simply adding the given product to this items array using its ID and then associating the array with it. Index product will store the instance of this product, and then we have quantity, which is the second argument, obviously. Okay, then we have has method, which takes product instance as well, returns Boolean, checks whether the key with the product ID exists within the items array. Then we have remove, which returns void. In other words, it doesn't return any value. Remove takes product again, check first of all whether the product exists. If it doesn't, then simply terminates the execution of this method. Otherwise, it's going to unset it on this items array. Then we have calculate shipping, which is basically the method when we are looping through all of the products, getting its shipping, and then summarize the values basically together to get the proper total using this number format, using 2 decimal places and so on. Now array sum will basically take whatever this array map will return, and array map is calling product shipping method on the instance of itself. In other words, using this order object instance, and we're passing items that we want to loop through, which is this property items where all of our products are stored. Now when we're passing this items, a single item obviously, into the product shipping, which is going to be, if we scroll up, as you can see here, we are adding these products as an array. So each instance of this argument to this product shipping will be represented with the index product and quantity. So if I scroll down here, we get this item. It returns float, which is basically going to be the total for the given item shipping. And within this method, we check if product is a gadget, then we check if the product is a furniture. Otherwise, we assume that this is going to be a vehicle type, and we calculate shipping based on what type of the product it is. And as you can see, gadget shipping takes product and quantity, returns float obviously as well. We check price multiplied by quantity, and if it's less than 50, then the price is going to be 5.25 for the shipping. Otherwise, it's going to be null. Basically, it's going to be free. Then for the furniture, again, we're checking quantity, this time multiplied by weight. If it's less than 100, then the shipping is going to be 15.30, otherwise it's going to be free as well. And for vehicle, we assume that all vehicles are going to be quite expensive, so we can provide a free shipping for any type of the vehicle. That's why we return straight away null for this. Now, just to show you what it's going to work like, I've written a test as well. First test correctly calculates shipping, so we instantiate the order class here, then we instantiate product of the gadget type, ID of the product type using this constant, then name of the product, which is going to be a watch, price of the product, and the weight of it. Then we have another product, which is a furniture, ID2, type furniture, name wardrobe, price, and weight. And then we have vehicle, exactly same situation. Obviously, weight and price is going to be slightly different here. And then we are adding these products to the order. So we have order, and then we add gadget, 3 of these gadgets, which will give us 3 times 30.45, should give us shipping of null, because if we go back to our order, you'll see that gadget, if the total price multiplied by quantity is less than 50, then it's going to give us 5.25. Otherwise, it's going to give us null. And obviously, 3 times 30.45 is going to be more than 50, at which point we're going to get null from this shipping method. Then we have for the furniture, we only have one furniture item. When the furniture item is under the weight of 100, it will give us shipping of 15.30, and this one is under the weight of 100. As you can see, it's only 10 kilos. Then we have vehicle, and all vehicles are free, as you may remember from the previous method. And then we are certain that the shipping, when we run the shipping method on this order instance, that it equals to 15.30, which is what we should get. And if it isn't, then we get, then we basically return this method as well. Then the second test correctly identifies product type, which is basically adding the creating a new product and then running this isGadget method on this gadget instance. When we pass through the second argument as type gadget, that should return true. This should return true for the furniture as well, because we're creating the furniture type of the product, and then vehicle as well. And if we run this test in a terminal, just PHP unit, and there we go, we get 2 tests, 4 assertions, all of which are passing, which is what we would expect. Okay, let's go back to the editor. Okay, so as you can see, one problem that we are going to be facing here, if at some point, if I just go back to the product class, at some point we are going to introduce different product type, then what we're going to have to do is modify both of these classes. And this is obviously against this open-close principle, because open-close principle says that entity should be open for extension, but closed for modification. And modification in this case would be adding another constant representing another type of the product. Then we would also have to add another is method to indicate whether the product is of a given type. Then within the order class, what we would have to do, if we scroll down, we have the shipping methods as well. So again, we would have to provide another method that would calculate the shipping for this given product type. Over time, our classes would become bloated with all those unnecessary methods, and obviously because of this, they would be much more difficult to maintain. If there was any change introduced to the way we calculate shipping, we would run into the situation where we have to spend lots and lots of time modifying all these methods. Now, there is a better way of doing this using a composition, where we can specify the interface for a given product type, then generate the different class for each type. Every time we introduce the new type, the new class is created, and each of these new classes will be responsible for calculating the shipping for its own type, because that's the only difference between all these products, really. If you can see here, if we just go back to the product, the only other thing that we do here, apart from calculating the shipping on the product, is just checking whether the given product is of a given type, which we can also handle in a slightly different way, making it a little bit more dynamic. Okay, so to start with, let's create the interface for our product types. Under the product directory, source product, let's create a new class and call it product contract. So product contract, and it's going to be of an interface type. So click on OK. There we go. Let's close all these bits here. Okay, so that's an interface. So obviously we don't provide any implementations. We only declare what methods any class that implements this interface should have. So, okay, we're going to start with the public function ID. Now, our product, later on, we're going to modify this class slightly, but it will have this, obviously, properties ID, name, price, weight, and so on. Now, why am I providing the ID methods? This is because when we specify these methods on the interface, that means that the class that implements them will have to have these methods. However, we cannot declare properties. We cannot declare contract for the properties. So even though these properties are available on the product instance, we will not have a guarantee that the class that implements this interface has this property. That's why we're going to implement the methods, which will basically return the value associated with these properties. Okay, let's add the dog block here. So this one will return integer, because our ID is going to be of an integer type, so get product ID. The next method that we will have to have is public function price. Again, public, because obviously all of the methods within the interface have to be public. And this one will return float. And let's just add quickly the dog block here as well, get product price for the summary, and let's indicate what data type these methods will return. I'm using PHP 7, that's why I can do it. If you're not using PHP 7, if you're using any lower version, then you unfortunately won't be able to specify what data type is going to be returned from the given method. But if you're using PHP 7, you can obviously do exactly the same as I'm doing now. So after the name of the method, brackets, then space, colon, space, and what data type. This one, it will return integer. Then for the price, we are going to have float. And then the next method will be public function weight, which will return the weight associated with the given product. And again, this is going to be float as well. And the dog block, returning float, and get product weight. And if we scroll up, I'm just going to create a few lines so we can shift the content up. The next one will be public function shipping. This one will also return float. So returns float and get shipping cost. And the last method that we need is going to be public function is. Now this method will take a class name, which is going to be of a string type, so I'll type hinted here, class name, and it will return boolean, because this is the method that will actually later on, if we just go back to the product, be used together with this is vehicle, is furniture, and any other given product type. I'll show you later on, obviously, when we get to this to the point when we actually implementing this method, you'll see where it actually is being used. Okay, let's now add the dog block here as well. Check if product has a given class name. If product type, now let's keep it like this. So it's basically going to compare the name of the class, which is representing a given type. And let's now remove all these spaces because we're finished with this interface. So that's all of the methods. We have ID, price, weight, shipping, and is method. We can save it and close it as well. Let's now go back to our product class, and here we are going to start by making this class abstract, so we won't be able to instantiate this class on its own. It will have to have child classes which will extend it. And let's remove all these constants. We no longer need them. We also don't need type ID because now each type is going to be represented by its own class. And if we scroll down, now if we obviously don't need type ID, we can remove this argument from here as well. And let's remove this param from a dog block. What next? And now is gadget, all these is methods we can also remove now. They are no longer needed. We're going to do it more dynamically. Now we're going to start with a public function ID, which is the contract on the interface we've just created, this product contract. As you can see, we've got this ID method here. We're going to implement all these methods within the parent product class, and then for the given type, we're only going to have the shipping method because all these IDs, obviously, all these getters can stay in one place because they only return value associated with the property. So again, this one is going to be of the integer type, and let's just return this ID. It's not the method, just a property. And let's quickly add the dog block here as well. It returns integer, get product ID. And one other thing that I wanted to do here is actually, rather than having these properties now as public, let's make them protected. So let's do it like this, protected. Now that we have getters, we no longer have to be able to access them through directly as properties. Let's change them to protected, and that will allow us the access from within the given product type, but not from the outside of any of these classes. Okay, so we have the ID. Next one is going to be price, so public function price, and it does return float, and return this price. Obviously, if you want to be able to access these properties from outside of the class instance, then obviously keep them as public. But I don't see any point now that we have these methods, these getter methods here. There's no point in having both available, in my opinion. So get product price, because you might want to modify these values as well before you return them through these getters. You may override them if you need to from any classes that will extend this product. Okay, then we have a public function weight, and this is going to be of a float type as well. The value returned from this method, obviously, then return this weight, and let's add the dog block as well. So get product weight. And the last method that we need to implement here is public function is, and it takes string class name and it returns Boolean. So let's indicate that it's Boolean. And then here we're going to return class name triple equal symbol, and we're going to use new reflection class. And we pass instance of itself to this reflection class, and then we run the method get short name, which is going to basically return something like, let me just show you here. Just going to scroll up a little bit. If we pass as an argument here, if we pass something like, let's say vehicle, then this vehicle as an argument here will be compared to the given class. Obviously, by default, this will return fully qualifying namespaced class name, and this reflection class will get just the name of the class without the namespace. So if our namespace is going to be, let's say, up, then product vehicle, then this will return, this get short name will simply return vehicle. And then we obviously comparing with a triple equal symbol, because this is going to be of a string type, and this method also returns a string. Vehicle against vehicle returns true, obviously, at which point this is method would return Boolean true as well. Okay, let's import this reflection class. Import it. By importing, I mean use this use reflection class here at the top. And let's add dog block here as well. So it takes string class name, returns Boolean, and check if product has a given class name. Now, how can we provide the functionality which we had previously on this product class, which allowed us to check for a given product type, like is gadget, is vehicle, and so on? Well, we can make use of the __ call, which is the magic PHP method, which is going to be triggered when we are trying to call the method on a given class instance that does not exist within this class. So let's use it in public function __ call, and this one will take two arguments. First one is going to be a string type, and it's going to be a name, and the second one will be array, which will represent arguments, so arguments. By default, I'm going to make it an empty array. And then what this method will return is simply Boolean true or false, because this method will only be triggered for our is starting method, which will return Boolean true or false. This is where we actually going to use this is method. From within this call will trigger this is method. But let's just start with how we actually going to obtain the name of the given class. Class name variable, we start with substring, and we give it a name of the method that's been called, and then we want to start from the second character. Now, how this works, basically name. Say we're going to have is gadget method that we call on the instance of of any class that actually extends this product. If we call this is gadget, first of all, what we need to remove this is from the beginning, and then the class name will be simply gadget. So using this substring, we pass this is gadget as the first argument, and then we indicate start from the after the second letter within this string. So we remove first and second, and we start after that. So this is what's going to be returned and stored within this class name after we filtered this using the substring function. Okay, so now that we have the name of the class that we are interested in, we check if exclamation mark this class exists, and we pass this class name variable as argument. If it doesn't, then throw new error, and this error will say something like invalid method call, and we pass class name as the first one, then colon, and the method we were trying to call on this class instance. So if it was isGadget, then this class name is going to be gadget, starting with the capital G. So gadget, and then method name would be isGadget. Okay, let's import this error as well. So import it again. If I scroll up, you'll see the use statement has been added with the error here at the top. Now this class method, class exists method doesn't exist. So let's quickly add this method. It will return Boolean. And it can be private, obviously, because we only need it for from within to use from within this product class. We return class exists, and then we provide the namespace to the current class, which is this product, and our product types will be stored within a new directory under the product. Let's call it a type. So this is where we're going to be looking for this given for these different types. So we concatenate this namespace, we append the namespace type to it, and then we add again the name of the class. So name class, name, there we go, which is this argument passed through to this method. And let's make it a string here, type hinted as well. So what we're going to get here in the instance of the gadget, for instance, that we will create a new type called gadget, and the namespace, this string here will return up product type gadget, and then this class exists will basically check with this class physically exists. Okay, so let's add the dot block here as well, string class name, and let's check if type class exists. So if it doesn't exist, then we're going to throw this error. Otherwise, we are going to return this is, and then we pass this class name as an argument, which is where we're basically going to compare this class name with the using this reflection class on the given instance, which will take, using this pseudo variable, the name of the class type, for instance gadget, and then get short name, which would return gadget, obviously, and compare it to if it was a gadget passed through as an argument, then it's going to return true, otherwise it's going to return false. Okay, so let's add dot blocks for this call. Method here returns bool, throws errors, that's fine, and then check if product is of a given type. And as you can see, that's the only method types. These are the only method types that we will be able to call. We will remove the first two characters from the method name, and then check if the class exists within this type directory here. And if it doesn't, obviously we throw the error. Otherwise, we check if the given class that we are comparing against is of this, has the same name. So in other words, is of the same type. Okay, so that's our product class refactored. Let's remove all these unnecessary spaces here, and I think we are ready now to move to the next video.